3, the function is positive. When I say it's positive, I'm looking for where it is above the x-axis. Notice I'm not talking about the slope. The slope of this line is negative, right? I'm not talking about the slope of the line. I'm talking about the entire function. It's positive up here above the x-axis, and it's going to be up above the x-axis for all values of x smaller than 3. When is it going to go down below my x-axis? Orange. It's going to go down here below my x-axis. That's not orange. When x's are hello, is anybody awake? For x's, this is less than 3 on this side of 3. So what would it be on this side of 3? Greater than 3. Come on, guys, it's the end of the day. Look alive. For x is greater than 3, the function is negative. Sorry, my handwriting is terrible. I don't know why it's so bad today. For x is greater than 3, the function is negative. Does that make sense? Like, are you hearing what I'm saying? Are you picking up what I'm putting down? You're just bored out of your mind? All right, example 2 says, again, use the graph to estimate the x and y intercepts. So, what are my x-intercepts? Where are they? Come in quick, come in quick. -4 and +3. So my x-intercepts, if I write them as ordered pairs, are found at -4, 0. And this time we have 2 of them. 3, 0. Where are my y-intercepts? Or my 1 y-intercept? Do I have 1, 2, none? It's at -12. Perfect. Here's my y-intercept. Is it -12, 0 or 0, -12? 0, -12. Now this one's a little bit different. When I'm talking about the positives and the negatives, I've got to be a little more specific. This time my function is, let me do that. My function is positive here and here, right? So it's positive if x is greater than 3, or if x is less than -4. And of course, this is where it's negative. It's negative when x is sandwiched between -4 and 3. The -4 is less than x, which is less than 3. That's where my function is negative. All right. I don't know how many of you guys know this, but I used to coach volleyball. So when I looked at this problem, I immediately thought of volleyball. I don't know why, but I did. It says sports. The graph shows the height of the ball for each second x that it is airborne. Use the graph to estimate the x and y intercepts of the function. Then describe where the function is positive and negative and interpret the meanings of the context of the situation. So what are my intercepts? This is my y-intercept, right? It would be 0, 4. Remember, we always put whether we go right or left first. So I don't go right or left, I just go straight up. So movement right or left is 0, up 4. Let's think about what that means. In my mind, I picture somebody serving the volleyball and my volleyball player being back there and boom, hitting the ball. It hits their arms at about 4 feet in the air, right? They ran to get there to get it, so they didn't get to do a very good job of setting it up for the setter to hit and then fight the ball, right? They just, boom, they just got it up. But that's okay, that happens sometimes, right? They, boom, got the ball up over the net. And what do we want to happen when it hits the other side? Do we want them to hit it back? Heck no. We want that ball to hit the floor. This ball is moving very slowly because 9 seconds later, what happens here at 9 seconds? The height of the ball is 0 feet in the air. So boom, what's that mean? The ball hits the floor. It's our point. I just got a point, right? I boom, hit that ball 4 feet in the air. It's airborne for 9 tremendously long seconds. And boom, hit the floor. Woo, we got a point. Go west, right? No? I don't know. I like a picture to go with the problem. Makes it a little more entertaining. Maybe I'm trying too hard. I don't know. But the y-intercept is 0, 4. The x-intercept is 9, 0. So what that means in terms of this situation is that, again, the ball was hit, when I'm explaining it, it was hit at 4 feet in the air. 9 seconds later, it hits the ground. Then it says, describe where the function is positive and negative. Well, this function is only positive. There is no negative parts. Never does this get below the x-axis. Why would it not make sense to have a negative part of this function? I mean, unless you're like Thor hitting the volleyball, coming down on it, that ball is not going to go down into the gym floor, is it? When it hits the floor, it's going to bounce back up. It doesn't make sense to say that the ball is negative feet into the floor. So therefore, our function is never, ever going to be negative. Does that make sense? So when it asks you to describe where the function is positive and negative, it's always positive because it doesn't make sense to look at the height of the ball being negative feet. Okay, I'm out of breath. Pretty bad when you get winded just from walking around in front of a classroom. Violet starts this semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. Where are my intercepts? Looking at the table. Well, think about the ordered pair. What ordered pair do I get? What numbers do I have when the intercepts, when I look at my intercepts? There's always a 0. When I'm looking at the table, what am I looking for? The zeros. So here, x is 0 when y is 150. I'm a visual learner. So in my mind, I picture that. I go over 0, up 150. So is that the x or y intercept up there? The y-intercept. Okay, again, I'm a visual learner. So I picture going over 40, up 0. That is the x-intercept. Now somebody explain what this means in terms of this situation. Don't all talk at once. I know you're very excited to explain this to me. What's this mean? Time, 0, balance. Time, balance. interpret. We'll call on somebody. Logan. Still thinking. Well, I'll think with you. Okay. Says she starts the semester with $150 in her account. Each day she spends $3.75. So thinking about that, we know we're talking about money in her lunch account. So she begins with how much money? She begins it with, or when she opens her account, we'll say, oh no, what's that? She opens her account with $150, right? Then what happens? She keeps spending, keeps spending, keeps spending. So what does this mean? She broke. She ain't got none, right? She ain't got no money. This is math class, not English, right? No, I'm just kidding. She doesn't have any money left after 40 days. So after 40 days, she broke. Well, if you're only spending $3.75 a day, apparently anybody. After 40 days, she has no money. And that is what that problem means. Well, if you put it in an account, you could only spend it on food. I bet you could. All right, we're almost finished. The last thing is to write a related function. So I'm going to show you what this means. A related function, first of all, in order for it to be a function, has to be f of x, right, or g of x, or h of x. But we have to have it set equal to 0. Okay? I want this to be 0. Before we were solving to get x by itself. Let's do that first. So it says, what's the solution of the equation? Well, you guys already know how to do this from our last chapter. How do I get x all by itself? Oh. Yep, take the 7 over. I'm going to subtract it from both sides. So 7 take away 7 is 0. 1 take away 7 is -6. Now what do I do to get x by itself? Divide both sides by -2. Property of equality says if I do it to this side, I got to do it to this side. -2 divided by -2 is a positive 1. 1 times x is x. -6 divided by -2 is a positive 3. Okay, so now what we want to do, rather than solve it like this, it asks me to write a related function. So somehow this function has to relate to what we're given. So I want to get rid of this 1 and get it to be 0. So I'm going to subtract 1 from both sides so that now it's equal to 0. Now what I'm going to do is I'm going to take that 0 and I'm going to replace it with f of x. So f of x is equal to -2x plus 6. This is my related function. Now, what I can do is graph this. So I have Desmos pulled up here. I'm going to go to Desmos and graph f of x equals -2x plus 6. And it asks me to look at where that line crosses the x-axis. Where does it cross the x-axis? Over here at 3. If you look back here, what did we get when we solved that equation? 3. Coincidence? I think not. You think it's coincidence? It's not. It's not coincidental. The graph intersects the x-axis at the point 3, 0. And the solution to the equation, if we solve it algebraically, is 3. So again, let's find the related function here. What do I do first to get the related function? Add 3 to both sides. Since it's a -3, I add 3. So I have x squared minus 4x plus 3 equals, I'm going to put an f of x here instead of a 0. Again, I'm going to go back to Desmos and I'm going to graph it. Again, I'm looking for where it crosses the x-axis. Where does it cross? 1 and 3. So there are my solutions, 1 and 3. If I was to solve this algebraically, which I realize that you don't know how to do that yet, you haven't been taught, but had you been taught to solve this algebraically, you would get the same answers, 1 and 3. We don't have to do it the hard way when we can get the related function and we can graph it and look for where it crosses the x-axis. Okay, so what you're going to do now is in your workbook, you have these problems that I would like for you to do. Page 175 and 176, numbers 1, 2, 10, 11, 12, 13, 15, 16, 17, and 20. Those will be due next week. And then I also want you to fill out the vocabulary here at the top of this page, okay? So we're working on vocabulary. We are working on these problems. If you know that you don't have the best internet at home and you would rather work on Alex while you're here at school, and then you want to work on your workbook assignment when you're at home, that's okay too. We've got 3 assignments we can be working on: vocabulary, practice problems, and Alex. Those are our 3 things that we need to be doing. Any questions?